Hello, everyone, and welcome to another episode of TWIML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. So I'm recording this intro in New York City, where I've been attending the O'Reilly AI and Strata conferences. I did a ton of great interviews here at the events, and I'm really looking forward to getting these posted over the next few weeks. Today, though, I've got a show that I know you're going to really enjoy. My guest this time is Angie Hugeback, who is Principal Data Scientist at Spare5, a company focused on helping its customers generate the high-quality training data sets that are so crucial to developing accurate machine learning models. In this show, Angie and I cover a bunch of the real-world practicalities of generating training data sets. We talk through the challenges faced by folks that need to label training data and how to develop a cohesive system for performing the various labeling tasks that you're likely to encounter. We discuss some of the ways that bias can creep into your training data and how to avoid it. And we explore some of the popular third-party options that companies look at for scaling training data production and how they differ. Before we dive into the interview, though, I really want to take a moment to acknowledge Spare5, who stepped up to sponsor this episode of the show. Now, I'm not going to spend time talking about their service here because Angie and I do cover that in the course of the interview, but I will say these three things. First, what Spare5 is doing is really cool, and if you have a training data problem, and you know who you are if you do, you should definitely take a look at what they've got to offer as you explore your options. Second, they've put together a great offer for 25 lucky TWIML Talk listeners, which you'll hear towards the end of the interview. And third, I'm just very grateful to Spare5 for helping to make this podcast possible for all of you, and I want to really encourage you all to show them some love. So please hit them up on Twitter. They're at Spare5, S-P-A-R-E, the number 5, and just thank them. Visit their website, sign up for a demo. All of these things let them know how much you appreciate this podcast and their support for it. As always, I'll be linking to Angie and the various things we mentioned on the show in the show notes, which you'll be able to find at twimlai.com/talk/6. And now, on to the interview. So, hey everybody, welcome to another episode of TWIML Talk. I've got Angie Hugeback, the Principal Data Scientist at Spare5 on the line. Angie, why don't you say hi?
Hi, everyone. Hi, Sam.
Hey, so happy to have you on here today.
Yeah, excited to be here. Yeah, I'm really looking forward to digging into some good stuff.
Awesome. So why don't we get started by having you give us a little bit about your background and how you got started in machine learning?
Yeah, sure. So I started out as a math major in college, and I took a stats class. I was at the University of Minnesota Duluth, and I really fell in love with the idea that, it was math, but it was applied, and you could learn about the world around you, through math. So I got really interested in statistics. I ended up getting my master's and PhD in statistics. So I got my PhD at the University of Chicago. And when I came out of school, so I had worked with my PhD advisor, was really big on teaching me how to creatively solve a problem, do, creative algorithm development, just start from the basics, what are you trying to do and construct from there. And I was really interested in doing that. I had a strong interest in machine learning types of topics. So when I came out of school, I had this idea, that I want to work in machine learning, but I want to do, the creative algorithm development and trying to find that. And at the time, the term data scientist didn't exist yet, but that's essentially what I was interested in doing. So it just took me some time from there to kind of blend between the traditional definition of statistician and sort of the engineering end of machine learning and find a good balance. And this is where I landed.
Awesome. Now, what were some of the kinds of problems that you were interested in grad school as a statistician looking into machine learning?
Yeah, sure. When I was doing my master's degree, I had a master's thesis problem that was really fun. There's the game Mastermind, where you have the little colored pegs and someone has a code, which is an ordering of colored pegs, and you're trying to guess through making proposals of, what you think the code might be and getting some feedback.
Right.
And so I had a lot of fun playing around with. I ended up building like a Metropolis Hastings importance sampling style algorithm to solve the game Mastermind in a very limited number of steps. And and the game is fairly straightforward when you're dealing with 6 pegs in the traditional sense. But then I was taking it up, well, what if it's 14 pegs or 50 pegs, and the space of the problem becomes incredibly complex. And I was really interested in, the Metropolis Hastings algorithm is kind of like a simulated annealing algorithm where you're able to explore a really high dimensional space very quickly and kind of rapidly move around in this space and figure out where you're making progress and work toward an optimal point. So that was fun. I also worked on a lot of problems in astronomy. So astronomy was something I'd always been interested in, but never had a chance to learn in school. So my advisor was awesome, Mark Coram. He invited me to, come on over into the astronomy department at the University of Chicago and talk to the professors there and figure out what kinds of problems they were working on, where I might be able to help out. So I did some work with quasars. I got to do some work on some solar science research. Got to do, I had a internship at NASA working on some solar research, continued to do some consulting with them for a while. And then the last project that always sticks out in my mind wasn't really part of my thesis work, but when I was in my PhD program, Netflix announced their Netflix Prize competition, which was it was a competition on predictive modeling to do movie ratings, right? So so they released this publicly available data set, and it was all these pairs of a movie ID and a user ID and then a rating. And then you were supposed to be able to predict how certain users would rate certain movies. And I played around with that problem for about 6 months. I came up with a great solution and that was competitive in the contest. But then through that, I actually came to a different understanding of what worked better in terms of actually making recommendations. So I built a movie recommender out of that and had it up on the web actually up until about 6 months ago. I was still using it to recommend movies for myself, and some of my friends are still using it. But so those kinds of problems were the things that I was generally interested in when I was going through school. Mm-hmm.
So does that mean it takes you less time to pick a movie to watch than it takes the rest of us?
Yeah, typically it actually works pretty well. I got to get it up and running good. Yeah, the best feature was being able to combine 2 movies. So you say, I want to see something that's like, I want to watch a movie that's like Footloose meets Fatal Attraction, or something like that, and then it would come up with some great recommendations crossing between those 2. That was really fun.
Oh, nice. You mentioned a whole bunch of really interesting stuff in there.
Yeah.
I want to mention, since you mentioned astronomy, I don't know if you've had a chance to hear the last Twiml Talk episode that I just posted is with Josh Bloom, who's a astronomy professor at Berkeley and also the CTO of a company that uses machine learning. I think you'll find it super interesting.
Thanks. I'll check it out. Oh, absolutely. Thanks.
And then you've given us an entree to go deep kind of quickly here. Metropolis Hastings importance sampling. What is that all about? Is that ML or stats or?
Good question. I think it's, it was sort of sitting in between the 2 fields and probably a little bit more in ML. Yeah. So Metropolis Hastings is one thing, and importance sampling is another.
Okay.
So Metropolis Hastings it's really just an optimization technique, for, maximizing a function in a high dimensional space, where rather than say, following the derivative or doing something more mathematical in that sense, you use a random component. So you start with a space in the high dimensional field. You say, okay, this is my initial starting point. And then you propose a point around there that you may go to next. And so you come up with a proposal function. So you say, okay, maybe my proposal is I pick one of my dimensions at random, and then I perturb that value a little bit with some random in some random distance in some direction, something like that. And you say, okay, that's my proposed point. And then you compare your function on that proposed point to the function on the initial value. Mm-hmm. And if you're in a better place and you say, oh yeah, this is a better place to go to, you'll always move there. But if it looks a little bit worse than your initial position, you'll still move there with some small probability. And so what that allows you to do is it allows you to move away from, local minima, things like that you might get stuck in. Yeah. And in many, many problems, it provides a kind of a rapid way to search through a very high dimensional space. So.
Would it be fair to say that if your proposal function was your slope in the n-dimensional space, that Metropolis Hastings would kind of approximate gradient descent?
Not exactly. No, the proposal is always it's basically a sampling. You're going to sample from the collection of all possible points that you might evaluate. Okay. Right. So, I suppose you could create a proposal function that says, I always select the point that follows, the slope at, that sort of thing. I suppose you can come up with that. But typically, your proposal is supposed to have a random component, and then there's the additional random component that you may choose it even if it moves in the wrong direction. Okay. Occasionally. Mm-hmm.
Oh, nice. So that raises a question for me. Coming from a strong stats background, mm-hmm. How do you feel like this guides your perspective as a data scientist? Data science has come to mean a whole ton of things. For many, it's heavy programming. For others, it's heavy data engineering. You obviously, it's heavy stats. Mm-hmm. Do you have kind of a philosophy on data science and kind of what that all means to you?
Yeah, definitely data science is a big umbrella covering a lot of different things. And, I think the whole field is evolving, right? And, and there's more and more applications in this area, many more people going into this field. Yeah. So, I'd say now there are a lot more people coming out of a computer science background going into this type of work. Whereas back, when I was coming out of school, it was almost 50-50. It was like machine learning was really sitting in between statistics and computer science. At least that's the way that it was at University of Chicago. Okay. And I do feel like I think I have I tend to approach problems more from the predictive modeling viewpoint. I do a lot with just constructing probabilities, likelihood estimation, things like that maybe wouldn't be as commonly used coming straight from a more computer science, engineering, machine learning perspective, where it may be more about deep learning and specific types of algorithms. So I guess I see a little bit of a difference there. But I have background in more traditional statistics, with just doing experimental design and doing more just classic kinds of testing issues and distribution comparisons and things like that. But I would say that's a small part of my daily work. It's one of those, we do A/B testing, we do things like that, and I'll participate in assisting with those kinds of experimental analysis. But typically I'm doing more, just constructing from probabilities, from likelihoods, working with predictive modeling, things like that to solve our product goals, things like that.
Are there things that you see commonly in the industry that you think would be different, or approaches that folks take that they might take differently if more people had a stats background?
Yeah, I'm biased, but yeah, I tend to think, I don't know. I see them blending, and I see, in people today that are coming out of, strong computer science programs with machine learning background, really there's quite a bit of overlap in terms of, the materials that's been taught and the skills that are there. So, so I'm not sure.
Okay. And so what are you up to now?
Yeah. So now I'm here at Spare 5. So what we do here at Spare 5, we collect training data for computer vision and natural language models. So other companies that are building out AI, building out their own machine learning models in computer vision and natural language types of problems need really good labeled training data in order to power, the algorithms that they're trying to build. And so that's what we do. So I got really interested in this space because at my prior company, we were building out some natural language models there, and we had some really good stuff. It was working really well, but we wanted to push it to the next level. And the thing that was preventing us was just getting that really good labeled data. And so I was thinking a lot about that problem. And then I heard that Darren, who's our CTO here, I heard that he was at Spare 5, and I heard about what they were doing. And I just saw a huge opportunity in terms of, I was like, AI is getting really big. Machine learning is getting really big. It's no longer kind of a fringe thing that a few companies are trying out. It's like to be in the space, to be competitive, companies need to be building these things out. And as far as I can see, the real bottleneck is in the training data. So, that was where I was excited to jump in and be a part of that business.
Nice. I think there's growing recognition that the availability of training data is one of the biggest issues that new entrants to, folks that are trying to apply machine learning to various problems take on. And, for a lot of people, they look at it and say, and I've heard this coming from several different angles, but, something along the lines of, soon, if not now, it'll be very difficult for a startup, for example, to, compete with Facebook or Google or, large company in industry, X, because they'll have all the data and the startup will not be able to gather it and label it and all that. Like, do you agree with that in general?
Oh, yeah. Or? Oh, yeah, absolutely. Absolutely. I mean, the way that I see, I think for quite a while, the focus was on the algorithms themselves and, how do we get better algorithms. But at this point, we have so many sophisticated algorithms and very flexible algorithms, right, for solving so many different types of problems that really the defining factor becomes the training data that you have underneath it to power it in terms of what you can actually do. So, yeah, I think that's a really valid concern. Although, I would say, it definitely depends on what industry you're trying to jump into. If you have a startup and they're trying to do something new, I think, I definitely think, if they have a specific problem that they're trying to tackle, that, requires a very specific type of data, I think there are still a lot of opportunities to get into that space if you have access to, right, the ability to get that labeled data that you need, right, which is where we come in.
Okay, so walk us through specifically what you guys are doing to help companies.
Sure, absolutely. So I guess, so I would start by saying, when customers come to us, typically the number one thing that they're looking for high quality data, right? And they need that data at scale. And so, and I would say, traditionally, companies may, initially they may start trying to label that data in-house, right? And they may say, everybody take a few hours and, look through this data, add some labels, that sort of thing, and then quickly find out like, okay, this is going to take forever and we don't really have the resources. And then a next step that companies sometimes would go to is trying to use these publicly available crowdsourcing, things like Mechanical Turk, where, there's a crowd out there. Maybe you can, put your data out to them and they can label it. But that can be just incredibly painful in terms of, you never know the quality of the work that you're getting back. It's like you end up having to design an entire workflow around just trying to QA the data that's coming back to you. You end up having to send the data out many, many times over again to multiple different people and try to assemble and make some sense out of the results that you're getting back.
Okay.
So that can be a real headache. So by the time customers get to us, so what we're doing instead is we handle all of that headache for you. So basically the customer comes to us, all they need to communicate to us is exactly what correctly labeled data constitutes to them, right? So they usually, the customer will present us with some examples. These are some images. Here's some example annotations. That would be the correct annotations for these images, that sort of thing. And from there, we do all the heavy lifting in terms of we will take on the task. We will create and generate that labeled data using our own community, which is like a thoroughly vetted community. We do all of the QA work, and we guarantee the level of quality coming back to you in your data, right? So if you say, these are the specs, this is exactly what correctly labeled data means to us, we want 95% of the data coming back to us to be correctly labeled to spec, right? Then that's what we can guarantee, and that's what we can provide. And so, yeah, so definitely it's quality is the major challenge that we're providing, just speed and scale. And then one other important piece is that we can provide diversity among the annotators. And so in particular, if there's a specific audience that the customer is interested in, so say they're building an AI model, and this AI model is going to be used by, women age, 20 to 30 typically, right, in the US, we can target annotators from that audience so that, the keywords or, whatever the labels that they're providing are relevant and the types of things that audience would typically use, which is really going to improve the performance for the models themselves, in those types of settings. So I would say, those are kind of the three kind of pillars of problems the customers have that we were able to solve for them.
Okay. Let's come back to the diversity angle, because that's super interesting. But even before you get there, if I'm a company and I want to solve a given problem in my industry, are you able to help me find the right data or augment the data that I do have with other data that might help me drive better predictability?
Yes. Yeah. So we don't go out and find like publicly available data sets for you. We are in the business of generating the data, but we definitely do augment data. So we've done data verification, sometimes, validation. Sometimes companies have already gone through, some steps of a process to assemble data on their own, but they're hitting the point where they're realizing like the quality is just not there. And what they need our community to help with is just going through and validating which ones are correct, which ones are incorrect, so that they can increase the quality there. We can definitely augment data. Maybe they have images that have certain annotations. Maybe the images have tags for objects that appear in the image, but the customer now wants to identify where in the image does that tag appear. So the tag might be dog, and they need to know exactly where in the image the dog is. And we can have our community either do pixel level polygon annotation around the dog in the image, do a bounding box annotation around the dog in the image, those types of things. So yeah, there's a really wide variety of things that we can do in that sense.
Okay. How much of this is best thought of as like a services or consulting engagement versus some platform that you guys have built up that automates a ton of the, this back end work?
I mean, it's really both. And I guess it depends on, the platform, I think, is really core and central to what we're doing and what we are able to do here. But I would say the consulting aspect on the front end of, making sure we design the task precisely to, making sure the customer is going to be very happy with the data that they receive and that it's going to do what they need it to do for their models is also absolutely essential. So I would say, we do have some customers that come to us that have, teams that have been working on these problems for a long time, and they know exactly what they want, and they've already got an idea of exactly how to kind of organize the logic of what a correct annotation looks like. And in those cases, it can be relatively straightforward for us to move that right into our platform. In other cases, we've got customers that they know the types of models they want to build. They've been struggling, and they may even want some initial consulting on what types of data are available to us. What can we do to improve improve the quality of their own models, and we can do some initial consulting there as well. So it really just depends on the customer. But basically, the consulting aspect is all setting up all the work, making sure we design the task correctly, going through an iterative process in the beginning with the customer where we say, okay, we think we understand your specs. We've designed the task the way we think will work. We run maybe we do 1,000 annotations for the customer, we turn that back to them and they verify, yes, this is what we're looking for. The annotators are understanding the task and this looks good before we go to scale.
Okay. And so you mentioned a bunch of things that customers have typically tried before they come to you.
Yeah.
Are you doing all those things as well, plus some other things, like, for example, farming the labeling out to multiple people and doing some kind of quorum or voting or something like that?
Right. So no.
Okay.
So yeah, the simple answer is no. So so we are not doing crowdsourcing. So first of all, we don't use Mechanical Turk. We don't use any external community. We use our own community through our Spare 5 app and through the web that are, everyone is fully vetted. We have great detailed information on our users. We get Facebook and LinkedIn data from our users. We do lots of survey and skill assessments. We're continuously monitoring their tasking behaviors in real time, monitoring the quality of the tasks that are being submitted. And so, but we are not crowdsourcing. So on the flip side, what we do is we get really, really good at understanding the quality of the work that the community members are able to provide, so that we're targeting the right users from the beginning, right? And then, so we've got predictive models in place to identify when a new task comes in. We can identify who are the users that we believe are most likely to do well on that task, and so we can initially target the right subset of our community. Then we turn the task on, and we have a real-time monitoring system. So we turn on that process, and then as soon as the task is live, all of that real-time monitoring is feeding back into our predictive models for quality assessment on the user. And so we're making real-time decisions about when to potentially remove access to a particular user because we're not seeing the level of quality that we need. And so we have a kind of that user quality model running in real time. And then we also have an additional layer, which is an answer quality model. So depending on the task, for some task types, there are other types of data and information available just based on the answer itself that's provided. And so we have that additional layer just to make sure that the answer itself is meeting our quality bar according to our models.
That's interesting. My initial reaction was, it sounds like crowdsourcing, but kind of, semantics here. But it sounds like the key distinction that you guys would make is that, with crowdsourcing, you kind of put the task out there and anyone can kind of take it. And what you guys are doing is, targeting it to specific people who you've developed a relationship with over time. Is that the right way to think about it?
That's true. And I think, it is a little bit semantics and just culturally how people use the terms. But I think that crowdsourcing often connotates that you're going to send a question to multiple users and then assemble a correct answer from those multiple users.
Okay.
Right. And so that's kind of the main distinction that I make. So a lot, oftentimes if we're talking to customers, especially if they've already got a lot of experience themselves working with Mechanical Turk, they're really interested in, what are the metrics you're using to decide whether you have enough consensus on a specific answer to move forward, and how many users do you need to ask each question, and that sort of thing. And in our setting, it's actually irrelevant. That's not the approach we use. That's not the perspective that we follow.
Okay. So is it fair then to think about this space as like Mechanical Turk is an API on top of the people, but you have to build everything. You're figuring out how to get them your tasks. You're figuring out how to do all this voting stuff so that you can get decent quality data, whatever.
You're writing the instructions. You're filtering, which users are you going to use, trying to track their quality, all of those things yourself.
Right. And then CrowdFlower, who I think a few months ago announced some specific offerings around labeling that I covered on the podcast. Like, they're kind of they actually originally were on Mechanical Turk, but I think they've got their own community now, and they're kind of a slightly higher level of abstraction that's doing a little bit more of the stuff, but still fundamentally we're going to take the task and push it to a bunch of people and choose the results. And you guys
Yep.
are, we're going to look at your problem and design a solution to get you quality data, and you don't have to
That's
think about
exactly
any of
right.
that other stuff.
That's exactly right.
Okay. And can you talk a little bit about, as a statistician, like what are some of the interesting problems that you've come up against in helping to build this for Spare 5?
Yeah, I mean, the most interesting and challenging problem for me was just how do we design a system and a platform that can work in a general sense at scale. So, when I started out, there was still a component of manual review internally just to make sure the various processes that we had in place were working as expected. And we had a lot of tailored, for this task type, we manage it in this way. And for this task type, we manage it in this way. Uh-huh. And so when I came in, that was one of my initial goals was how do I come to understand this entire system with all the complexity for so many different types of tasks. We have objective tasks, we have subjective tasks, we're looking at images, we're looking at text, we're doing all of these different types of problems. How do we develop kind of a cohesive system to attack and address all of these different task types and ensure the right level of quality? So that was really exciting for me, and and that's been the focus, over the last several months, and now we're there, and so that to me has just been a really exciting accomplishment.
That sounds pretty huge. Can you talk to whatever level of detail you can? About
I know
pipeline / tech stack.
Oh yeah. Oh, sorry. Could you clarify the last part?
Oh, your data science pipeline / technology stack / kind of anything that can help folks get a sense for, as they're building labeling platforms, what are some of the things that they need to consider?
Sure. Well, so I can tell you just for the tech stack that we have here. So on the back end, we're using Ruby. We use R, Postgres, and then we have a lot of different AWS services. Okay. And then on the front end, we have a web client as well as a native iOS application. And so let's see. So I think that there's a little bit. Sorry, maybe you can give me a little more guidance on exactly what direction you want to.
Oh yeah, so that is very helpful on understanding the tech platform. It sounds like you guys are taking advantage of the cloud and AWS in particular. Yeah. As when you thought about this challenge of, okay, we've got all these different types of data. How do we unify this into a single platform that eliminates a lot of the manual steps that you described? Mm-hmm. Are there any lessons that you've learned about building data science pipelines that helped you achieve that goal that you think would be transferable to other people?
Yeah, and I don't know that this is specific to data labeling. I would say one thing that I've learned that's worked really well, both here and in previous companies that I've been in terms of integrating data science with the existing tech and existing product, is I think what's really essential is you want your data scientists to be focused on prototyping, like rapid prototyping. You want them to be really nimble in terms of, hey, if something about the product changes next week, we want to be able to dig into the guts of our models, make our changes really quickly, and be able to push that back out into production in a seamless way. And you don't want your data scientists to have to be spending the majority of their time, maintaining and these larger systems, and really having to be so focused on the engineering side in terms of, let's make sure everything's staying up and stable and doing what it needs to be doing. So one solution in the team that I led previously at my previous company, one solution that we came to, which worked really well, was we developed. So we still wanted our data scientists to be able to prototype as quickly as possible. So I would say, R is fantastic in terms of prototyping. You have your, the graphics and visualization component is, is unsurpassed by any other software. You have Python has lots of packages that are fantastic. You can definitely do some good data visualization there, but our team was focused on R. And so we wanted our teams to be able to do their modeling. And we had a lot of predictive modeling kinds of work going on there. We wanted our data scientists to be able to do the predictive modeling in R and hand off the actual model component to the larger system in such a way that, it was sort of plug it in so that you have, these are the inputs coming into the model. These are the outputs coming out of R. And we want that, we want to be able to just take that chunk of code that is the model, pass that over into production and get that plugged in and going at scale. And that, what worked really well, what we've done in both situations is we've actually used RServe. It doesn't have a fabulous amount of documentation out there, but it works really well. And there's so building out a system with RServe, building out some software around that to allow kind of just the kind of input output portion to be handed over, and so that you can have other standard systems, picking it up and hitting your models, and, moving that all into the cloud so that you can, if you start getting a lot more volume hitting your model than you originally anticipated, right, you can just spin up some additional clusters and manage that traffic.
Is RServe open source?
Yes. Mm-hmm.
Okay. And so what I think what I'm hearing is that you've got the exploration and the model development, that's all happening in R, and then you're able to take those models and essentially deploy them into RServe and use that for prediction, as opposed to having to throw that over to an engineering group to build them up using something else.
Yeah, exactly. And what I would say too is, it really depends on the algorithm that you come up with. If you're prototyping and in the end you end up using something that's mathematically very simple, then maybe you just pass along, your pseudocode, you know what I mean? Of like, okay, right. These are the kinds of things that I'm doing. These are the steps, and you have that re-implemented in a faster language. But if you're using, there are many, many fantastic predictive modeling packages available directly in R. And if you get your system set up correctly, we were using, we had predictive models with, 1,000 features, in real time, returning results in about 100 milliseconds, right? Coming straight out of R. If all you're hitting R for is the actual modeling component, right? Once it's already constructed. So, and I think keeping the model code in R in that sense just makes it all that much easier for, any modifications down the line that need to be made. And I think another layer that you can add on top of that, which can work really well is if you can start to integrate some automated model rebuilding mechanisms, right? So you've got one system going on that's pulling in new data, continuously updating your models, and then you've got another system that's just plugging into the existing most current model to actually get the results. That can work really well.
It's interesting. I'm glad you raised that. I was thinking about that as well. And if you what you've done to address like model drift over time, and if you've been able to build in like 360-degree feedback loops, that kind of thing.
Yeah. So just somewhat. I haven't gone too deep on those sorts of things. So what I have some tricks that I like to use in terms of kind of model monitoring when you are doing automatic updates and things. And so there's various kinds of sanity checks. There's a paper out of Microsoft that was just fantastic in terms of like, these are all the things that can go wrong when you put your model on autopilot, and right. And these are the things that you need to be monitoring. And so with just, they're like 7 step-by-step suggestions in terms of things that you might want to get implemented. And that's fantastic. I can try and pull up that paper for you.
Oh, that would be amazing. That sounds like a great resource.
Yes.
Is it relatively recent?
I believe it was in the last couple of years. Yeah, I've got to look it up. Mm-hmm. Just making a note here.
Yep. And then you guys are focused on computer vision and natural language. Is that right?
Yeah, that's right. That's our focus right now. Mm-hmm.
And how do those domains influence the approach you've taken?
Yeah, that's an interesting question. I mean, so clearly with computer vision, we're dealing with image data, right? And so I think it's had a huge influence in terms of the types of tooling that we're building out to allow our users to correctly annotate the data. Our end resulting data is only as good as the tooling allows for user accuracy, right? So it's definitely had a major influence in the types of tasks, the types of tooling, things like that we've been designing. But I would say at this point in the general system for QA that we've constructed, that is general. It's not specific in those areas. But what we would like to do, continue, I guess, delving into is internally. What can we do in terms of natural language and computer vision modeling ourselves internally to improve the quality of the results itself, and that's something that we're just now starting to dive into.
Okay, so in providing the services that you guys provide, are you needing to get into things like deep learning and other things, or are these more the things that the customers would use to train with the data that you're providing?
Yeah, that's right. So we purely handle delivery of the training data. So we can do some consulting in terms of, if you use data like this, this is how, that may affect the models, but it's really just more of a consulting aspect. We're not doing any of the model training ourselves. We're not hosting any models, nothing like that.
Okay. Interesting. Do you have a set of, is there like a top 3 list of things that you would want everyone to know about training data?
Oh, that's a good question. Let's see. Yeah, I think, I think anyone who's got, any experience in the field knows that, your model is only as good as your training data. If your training data really only represents, a specific subset of the space in which you expect your model to function, then, you're definitely going to have low accuracy in areas where you haven't provided as much training data. So definitely you need good coverage in terms of, whatever the inputs that you're going to be anticipating that will be coming into this final model that you build. You want to make sure that your training data represents those inputs as closely as possible in order to get the best results.
Okay. One more?
Well, and I think, I guess one interesting thing to think about is it depends. I think in the computer vision and natural language applications that we're focused on, the quality of the data is really essential. But in other areas, there are situations where you can get away with, lower quality training data, and the model is, as long as the patterns are there and the patterns are present, your model may still be able to pick up those patterns, right? And so I guess just keeping in mind what level of quality is important or essential for the type of model that you're building and the type of methods that you're using, there can be some variation there.
Okay, how would you characterize the scenarios in which you can get away with the lower quality training data?
I would say definitely when your model is more about summarizing and generalizing the data, then having a few odd observations in there isn't going to dramatically affect that summary. Are
there any examples that come to mind of customer SpaceX?
Let's see. Well, I don't know. There's some. Well, so here's an interesting example. It's a little bit on the edge of what you're talking about here. So, so Sentient is a customer of ours. They're a provider of AI. We have a task that we've been running for them for quite some time now. What they're interested in understanding is user perception of similarities between shoes. So they're building out, they have models that they're building out that are trying to decide what shoes belong together, not from some specific taxonomy or, hierarchy that some human person wrote down, but, like, oh, first you go by color and then by size, or nothing like that. What they want to understand is what a human person looking at a collection of shoes, if you say, here's one pair of shoes, now look at these other 10 pair of shoes, which one is most similar? And they're really trying to understand the human's perspective of, which of these 10 shoes do you think is similar? So it's a very ambiguous task. It doesn't actually have a right or a wrong answer. But when we throw this task out to our users and we return the data back to Sentient, they've had very good success in terms of improving their models, which, in terms of what types of results they're able to surface as a result of getting a very deep understanding of what similarity means at a human level. So, there are many, many varying degrees of, of going, to ambiguity versus, essentially a very precise, correct answer. And it just absolutely depends on the model that you're trying to build, exactly what you need.
Okay. In that example, are they ultimately trying to make recommendations or do something else?
I believe so.
Okay. Man, I feel like I should have asked you about customer examples way sooner. That was awesome.
Time ago.
Are there other interesting kind of use cases that you guys have taken on that we can talk about?
Sure. Yeah. Well, so here's one we did recently. This was kind of different for us, and it was a lot of fun. So there's a company called init.ai, and they're building AI chatbot technology. And so they're interested in building these chatbots in specific contexts. And so they need conversation data, like they need, a text of conversations in these contexts, and they're having a difficult time going out and, finding that data publicly available, things like that. And so, so we were talking with them, we've already typically done lots of categorization of text. We'll do what's called like aspect opinion linking of text, various kinds of NL tasks. But what we ended up doing for Init was we actually helped them produce the conversations, and then took those conversations and labeled the data, the text of those conversations. So we actually ended up designing a task that we put out to our community, which was, pretend you're selling flowers, and and now be the person selling flowers, and then to another user we're saying, pretend you're buying flowers, and maybe we give some guidance, things that the customer is interested in learning more about, and we actually send the task back and forth to collect a complete conversation.
Wow.
So I think we assembled something, I forget, I think it was something like 10,000 conversations that we assembled, and then for each of those conversations we went back and we did the labeling that they needed in order to understand the content of what's going on, in those conversations, to help train the AI models that they're building. So that was fun. That was fun for us in terms of just designing it out, but it was also fun for the community. We got so much feedback from people saying like, I love this. I could do this all day, because you're just, and the conversations were fantastic. So, I mean, it was a lot of fun.
That's awesome. Yeah. That reminds me of someone had, a month ago or so, set up basically these 3 kind of conversational chatbots in a chat room, and they were just kind of talking to each other. God. And he would sit there and monitor, and when they got stuck, he'd just throw out some random thing to get them talking to one another.
Oh, that's fabulous. Oh, I gotta look that up. That's fantastic.
That's all. So I don't know that I'll be able to find that, but if I can, I'll stick it in the show notes.
Okay, that'd be great. That'd be fantastic.
So one of your top 3 things was subsetting the space, which reminded me that we needed to talk about this diversity point.
Oh, right.
I want you to kind of start us off in this discussion with, the examples that come to mind for you of like where it's been done really poorly.
Well, actually, I have an example. This is something we actually had an article in TechCrunch about this recently. So we've been thinking about this a lot, just since, it's obviously a benefit that we can provide to our customers to actually get the diversity and the community that they need. But so we did a little experiment in-house. So we started thinking about the question of, how different are the results? Like, how different does the training data look if you're sampling, various types of populations? And so and it turns out we really didn't have to dig very deep. So one of the first data sets that I went to analyze, we had a task that we had put out to our users just as sort of a fun mental break once in a while, which was called Rate the Puppies. And so we just show you pictures of puppies, and then you rate them from 1 to 5 stars. Cute or okay, maybe not so cute. And so we'd been collecting that data actually over quite a long period of time, just, a few puppies to rate, here and there for our users. And so the first thing I thought was, okay, let me just take a look at the data and see how the ratings differ by gender. And so I split the data up by gender, and it was just dramatic and obvious difference that the women were rating the puppies as cuter consistently across the board, across all puppies. And and there was a wider gap on the cuter end of the spectrum, and the gap was more narrow on the not so cute end of the spectrum. But it was still there. And and it was just striking, right? It's a simple example, and okay, well, how does it matter? How cute the women and the men are rating the puppies? Okay, probably not, but it's such a clear example of the differences that you can get in the training data itself, right? Just by sampling a different population. Right. And of course, the training data is what's guiding your model in terms of the output that's coming out the other end. Mm-hmm. Yeah. But yeah, so that's an article in TechCrunch. We can put a link to that article as well.
Okay, nice. And so do you run into any challenges in identifying diverse communities to target? Like, what are the challenges generally that come up for you guys in trying to solve this problem for people?
Sure. So each of our customers is going to have their own demographic that they are targeting, right? And so at this point, we have a broad international community. We have many, many users in the US. We also have we have a good presence across just internationally. And we have good data in terms of who our users are, because we put out surveys to collect demographic information. We put out many different surveys to our users, that they're compensated for completing these surveys to be able to collect that information. So we have a good understanding of our current user base, which is very diverse. But we occasionally still have a customer come in and ask for something very specific that we haven't targeted before. So they potentially could say, we have this task and we need, we need experts in bird identification to label these images of birds, and tell us precisely what species of bird, this is, something like that. Right. And so when that comes up, we can go out and survey our community and find out, in our broad community, do we have people who are able to do this type of classification already? We can identify them. And if we find that we don't have enough members in the community yet to meet the velocity needs or, the volume needs for the customer, then we can go out and do specific targeting to bring, online marketing to bring those individuals into our community. And we've had good success with that.
Okay. So we've talked about demographic targeting primarily thus far. Have you ever done anything with psychographic targeting? Like,
right.
I don't know, for whatever reason, I'm thinking, hey, we want this to be answered by Myers-Briggs ENTJs or.
Absolutely. Yeah, we've definitely talked about it. There are all sorts of interesting just personality profiles out there. And that's what's kind of lovely, is because we do have this stable community that's working with us, is if we put a survey out to the community, right, and we compensate them for their time in completing that survey, we can get any data that we need. So it's actually very easy for us to target the user that the customer is interested in.
Okay. And this is a little bit of an aside, but I often think that in the example of like Uber ratings, I think that there's probably, well, not probably, there are, 4 average raters and there are 3 average raters, like, hard graders and easy graders. I don't have the impression that, an Uber, for example, would normalize, a person's rating against their average rating.
Right, because it has a strict interpretation, right? 3 stars, exactly, 3 stars. That's what the user said. Yeah.
Does anyone do something like that, or to what degree, to your knowledge, do folks think about that in thinking about like rating schemes, and what's the current kind of thinking in the industry around that kind of stuff?
Yeah. So this is a little outside of my area.
Yeah,
of
it's
expertise.
totally random.
Yeah, that's okay. Yeah, I mean, I actually thought about this quite a bit when I was working on the Netflix prize competition, because in that case we have the 1 to 5 stars rating system, right. And so I went really deep in just in understanding like what are these different user profiles, or what types of users are out there, and what do these distributions generally look like. And it's like on a 1 to 5 star rating system, you basically get 1s, 4s, and 5s, and occasionally a 3. You almost never get a 2, and So I don't know. So I have some interesting tidbits, and thoughts about that in general. But currently at Spare 5, from our perspective, we occasionally do ratings tasks. It's not one of the common customer requirements. And we'll talk with the customer about whether is a binary answer going to be more informative for them, or a 3-level answer versus a 5-star answer. And so we do have some experience and background in thinking about what type of data is going to come out of those different kinds of rating systems. And beside just the rating system itself, the wording of the question is so important in terms of, the words that you use. If you have a 3-layer system, do you say, perfect, okay, terrible, or do you make it more, more nuanced, right? And you're going to get different data based on different wording that you use, which actually to segue into, another, like a whole other area of things that we are thinking about constantly here at Spare 5 is just in the wording and the framing of the question is just such an essential piece of what we do here. Whether, even if it's not a rating question, even if it's a totally open-ended, writing captions for an image, or free text keywords versus, very objective taxonomy, categorization, things like that. The wording of the question makes all the difference, right? And so in our case, we actually take our users through, there's a complete process. So when a new task comes in, right, we're iterating with the customer, trying to design the task. When we start preparing our users to complete that task, we will typically put up a tutorial. We'll start with a tutorial, so the user's just working through the tutorial. They can work through it as many times as they want, and it's giving them direct feedback on whether they're doing what's appropriate for the task. The next stage is a qualifier, which is more like a quiz. You don't get the feedback as you're doing it. At the end, you find out if you passed or not. And typically, we won't allow users to continue into the task without completing the qualifier. Right. And so we have instructions for the task that we're writing. We have the tutorial that we're writing. We have the qualifier that we're writing. And then we have the task itself and the questions that we're designing inside the task, right? And all of the wording, logic, the orientation and design of that information on the page, it is all part of the whole formula of how do you get the right data coming out at the end. And so that's a really important piece that I think people that are new to this field, or just finding out about it for the first time, don't realize what an intense amount of work and thought and effort goes into getting that right.
That's really interesting. To what degree are you relying on, or do you have the benefit of relying on other folks' research to figure some of this stuff out, or is it all empirical analysis on your part?
Right. So there is definitely a lot of great learning already out there, that's been published. So we have Dan Weld is a computer science professor at UW, and he consults with us regularly. He's been fantastic. He's a crowdsourcing expert, and he's been fantastic about pointing us to, all the good research out there about different things that have been tried in terms of instructions and tutorials and designing tasks and all those kinds of things. So there's definitely a lot of learning there. But I would say, given that, we are working in a somewhat different space, in that we are not doing traditional crowdsourcing. We are not, farming questions out to multiple users at a time. And so there has been a lot of just individualized learning on our part in terms of how do we work with our users, and what level are our users at, and how do we bring them through the training process to get them to the level that we need. So there's definitely a lot of internal learning, and I would say, each time we do another task, we have certain task types that we've done again and again and again at this point, and we're learning each time we do them along the way how to make refinements, how to optimize that process, how to make it even more clear. Anything that we can do to make the instructions more clear, it just saves in terms of efficiency because we have that many more answers coming through that are actually accepted and allowed into the deliverable for the customer. Nice.
I think we're coming up on an hour. Anything else that you'd like to share with the audience?
Yes, absolutely. Well, I would say, if anyone is interested in getting in touch with us, there's a couple of ways to get in touch. You can always head over to spare5.com. You can also email me directly. I'm Angie at spare5.com. And I guess one other thing that we wanted to let the listeners know about, so we have a blog series that we started a couple of months ago. It's called Conversations in Machine Learning, and it's just all about any interesting new applications in AI and ML, things that are popping up all over at various companies that we're watching in this space. And for your listeners, we're offering a fantastically fabulous Spare 5 t-shirt to the first 25 people who subscribe to the blog series. And if anyone's interested, they can sign up it's spare5.com/podcast.
Well, that's awesome. And I'll include a link to that, of course, in the show notes.
Okay, wonderful. Thanks.
Awesome. Well, thanks so much, Angie. This has been a great conversation, and I really enjoyed it. And,
Me too. Thanks.
Catch you next time. Thank you.
Yeah, absolutely. Thanks, Sam.
All right. Thanks. Bye-bye. All right, everyone. That's it for today's show. Thanks so much for listening. And thanks once again to Spare 5 for sponsoring the show. Please don't forget to sign up for their t-shirt offer at spare5.com/podcast. And of course, we both want to hear your feedback. On Twitter, I'm at TwimlAI, TWIMLAI, and Spare 5 is simply at Spare5. Reach out to us and let us know what you thought about the conversation. Thanks so much for your continued support, and catch you next time.